Greetings, students, and welcome to today's exploration of an intriguing problem from LeetCode, specifically Problem 125, titled Valid Palindrome. In this challenge, we are tasked with determining whether a given string qualifies as a palindrome. For clarity, a palindrome is a sequence that reads identically when traversed from either end. Our input consists of a singular string, which may include alphanumeric characters and spaces. Crucially, we must disregard case sensitivity and any non-alphanumeric characters during our evaluation. Let's consider a compelling example. The phrase, a man, a plan, a canal, Panama. When we meticulously eliminate spaces and punctuation while normalizing the case, we find that it distills down to Amana Plana Canal Panama. As such, this sequence indeed reads the same in both directions, affirming its status as a palindrome. Our objective, therefore, is to return a Boolean value, true if the string is a palindrome and false otherwise. Let us delve deeper into this captivating problem. The two pointers technique is a highly effective strategy used to tackle various problems involving arrays or linked lists. Imagine having two friends standing at opposite ends of a long table. Each friend represents a pointer, and they both start moving towards each other. This approach allows for quick comparisons and manipulations of elements, making it possible to solve problems efficiently. Typically, the pointers begin at different positions, such as the start and end of an array, and they move toward one another based on specific rules defined by the problem. This technique achieves linear time complexity, which is much faster than solutions that involve nested loops, often resulting in quadratic complexity. The strength of the two pointers technique lies in its ability to simplify the problem-solving process. It's particularly useful in tasks like detecting palindromes, where you check if a string reads the same forwards and backwards. By adjusting the pointers based on conditions, you can systematically explore the data, leading to optimal solutions without unnecessary computations. By mastering this technique, you'll enhance your programming skills and gain a deeper understanding of how to navigate data structures efficiently. In this example, we're using the two pointers technique to solve a problem related to arrays. First, we initialize two pointers, one starting from the beginning of the array, called left, and the other from the end, named right. This setup allows us to efficiently compare elements from both ends of the array. Next, we prepare an empty list called result, to store the sums of values at both pointers. As we enter the loop, we continue until the left pointer is less than or equal to the right pointer. Inside the loop, we add the values at these two pointers and append their sum to our result list. After that, we move the left pointer one step to the right and the right pointer one step to the left. This way, we systematically work our way toward the center of the array. Finally, once the loop is complete, we return the result list containing the sums we calculated. This technique is efficient and helps us process the array in a straightforward manner. String manipulation refers to the various methods and techniques used to modify, analyze, and interact with sequences of characters, which we call strings. Think of strings like a row of beads, where each bead represents a character. Just as you can add, remove, or rearrange beads, you can perform operations on strings like concatenation, slicing, searching, and replacing parts of the string. These operations are vital in many areas of computer science, from validating user input to processing text in applications like chatbots. Imagine trying to read a long book. If the text is hard to manipulate or understand, it becomes frustrating. Similarly, efficient string manipulation makes working with text data smoother and faster. Most programming languages provide built-in functions for string operations, such as finding a string's length or splitting it into smaller parts. Understanding the underlying algorithms, like those used for searching or sorting strings, can enhance your skills even further. Mastering string manipulation is essential for anyone aiming to succeed in computer science and software development. Let's dive into the function shown here, which reverses a given string. The function is called reverse string and takes one parameter, input star. First, we initialize an empty string called reversed star. Think of this as our container where we'll build the reversed version of the original string. Next, we use a loop to go through each character of input star in reverse order. The slicing notation input star -1 is a neat trick in Python that allows us to easily reverse the string without having to manually swap characters. As we loop through each character, we append it to reversed str. It's like adding pieces to a puzzle. With each character, we come closer to the final picture. Finally, once the loop is complete, we return reverse str, which now holds the reverse string. For example, when we call reverse string hello, the output will be ole. This simple function illustrates how string manipulation works, and it's a great building block for more complex tasks, like checking for palindromes. Input validation with character comparison is essential in computer science. Think of it as a security guard checking IDs at the entrance of a club. When users provide input, we need to ensure it meets specific criteria, like allowed characters or the correct format. This process helps us determine whether to accept or reject that input. Imagine filling out a form online. If you type letters where numbers are expected, the system should flag that mistake. Neglecting input validation can lead to data corruption or security issues, like unauthorized access or attacks on the system. To implement this, we often loop through each character in the input string, checking it against our rules. For instance, we might verify if a character is a letter or a number. If any character doesn't meet the criteria, we can reject the input and ask the user to correct it. This method ensures our data is reliable and secure, which is crucial for effective software development. Let's explore how we can validate input by checking for alphabetical characters using the function validateInput. This function takes an input string and starts by creating an empty list called valid chars. Think of this list as a basket where we will only collect the characters we need. As we go through each character in the input string, we check if it's an alphabetic character using the isalpha method. If it is, we place that character into our basket, valid chars. This means that any numbers or special symbols are simply ignored, helping us focus on the letters. Finally, we return the contents of our basket as a single string by joining the characters together. For example, if we input hello123, the output will be hello. All the non-letter characters are filtered out. This method ensures our input is clean and ready for further processing, like checking for a palindrome. To solve LeetCode problem 125, which checks if a string is a palindrome while ignoring non-alphanumeric characters and cases, we can follow a step-by-step algorithm. First, we initialize 2 pointers, left at the start of the string and right at the end. This will help us compare characters from both ends. Next, we use a while loop that continues until left is less than right. Inside the loop, we check if the characters at these pointers are alphanumeric. If not, we skip them by moving the pointers accordingly. Once we have valid characters, we convert them to lowercase and compare them. If they don't match, we return false, indicating the string is not a palindrome. If they do match, we move the pointers closer together. If we finish the loop without mismatches, we return true, confirming the string is a palindrome. It's also important to handle edge cases, like empty strings, which are trivially palindromes. This approach is efficient, running in O(n) time with O1 additional space. By using pointers and string methods, we simplify our solution while ensuring clarity in our logic. In this problem, we are tasked with determining whether a given string is a palindrome, while strictly considering only alphanumeric characters and disregarding case sensitivity. A palindrome reads identically from both ends. Key constraints include that the input string can vary in length from 0 to 200,000 characters and consists solely of printable ASCII characters. These constraints necessitate an efficient approach to ensure our solution performs well, even with the upper limits of input size. The Python function isPalindrome is designed to determine if a string reads the same forwards and backwards, ignoring non-alphanumeric characters and case differences. This is a classic problem that can be efficiently solved using a 2-pointer technique. We start by placing 2 pointers, one at the beginning of the string, labeled left, and the other at the end, labeled right. The while loop continues as long as left is less than right, which means we are still comparing valid characters. Within this loop, we have inner loops that move the left pointer to skip any non-alphanumeric characters. This is crucial because we want only meaningful characters for our palindrome check, and the asalnum method helps us filter those out. Once we find valid characters, we compare them, ignoring their case by converting them to lowercase. If the characters differ, we return false, indicating the string isn't a palindrome. If they match, we move both pointers inward and continue checking. If we reach a point where left meets or passes right without discrepancies, we conclude the string is a palindrome and return true. This method is efficient, operating in linear time, ON, with minimal additional space, O1. It highlights the effective use of pointer manipulation and string processing in Python, providing a clear example of problem-solving principles in computer science. Let's analyze the time and space complexity of the algorithm used to determine if a string is a valid palindrome. First, we have the time complexity, which is ON. This means that the algorithm needs to look at each character in the string at least once. Imagine reading a book to check if it's the same backward as forward. If the book has n pages, you'll need to read all n pages. This linear relationship with the length of the string is what gives us ON time complexity. Next, let's discuss space complexity, which is O1. In this case, the algorithm only uses a fixed number of extra variables, regardless of how long the input string is. Think of it like using a single calculator to do your math problems. Whether you're solving one problem or 100, you still only need that one calculator. This constant space usage makes the algorithm efficient in terms of memory as well. Understanding these complexities helps us appreciate how the algorithm works and its efficiency.